We are going to review what a function is. So we have this little foldable. So function or not a function. Go ahead and write these two things down. To be a function, x's cannot repeat, and it will pass the vertical line test. Go ahead and write that down. Okay, so let's review what the vertical line test is. So if you look at your vocabulary that's in your Unit 2 divider, this explains the vertical line test. It says the visual way to determine if a curve is a graph of a function or not. So what you do, this is your original, it looks like a U shape. And to determine if it's a function or not, you draw vertical lines down it and you put dots where it crosses the curve. And if you have two dots on one line, then it's not a function. And the way that you'll see it this year, last year you saw it and it was just like, is this a function? This year when you see it, the way it's going to read is a function, y is a function of x. So write that out to the side. Y is a function of x. That's how it's going to be worded, which sounds super confusing, but it actually isn't. No? Y is a function of x. Instead of just, is it a function? It's a function. You would say y is a function of x. So don't get confused whenever you see it worded that way. Okay, so let's go back over here. And we are going to look at what's inside, the problems that are inside. And we are going to determine if it's a function or not. So we're going to do a couple together. And then I'm going to let you spend some time doing it. So determine if y is a function of x, we would need to look at if x is repeat, and then the vertical line test. So on this table, look at the x values. Do any of the x values repeat? Yes. So circle the ones that repeat. That is the reason it is not a function, because -5 repeats. See how -5 is with -3 and -5 is with 7. So this is a no. We're just answering yes or no. Yes, it is a function. No, it's not a function. So if you look at your x's, so remember it's xy, 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 and xy. So you look at all the x values. Do any of the x values repeat? We'll go ahead and just name them. 1, 2, 3, 4, and 5. They don't repeat, so it is a function. So you're looking to see if x's repeat. Okay, go ahead and spend some time finishing this one up. Then we're going to check it in 3 minutes. Okay, let's check your work. Number 3, it is a function, because if you draw vertical lines, it will only cross each vertical line one time. So that is a yes. Number 4, 5 is with 1 and 4 is with 1. But none of the x's repeat. Remember, this is x, this is y. The y's actually repeat, so this is a yes. 5, if you do your vertical lines, it only crosses once, so it is a function. Number 6, we have 6 with -1, 5 with 0, 2 with -4, and 1 with 0. This is a function. X's do not repeat. 7, draw your vertical lines to test out the vertical line test. It crosses each vertical line twice. Even if it's just one that it crosses twice, it's still not a function. Number 8, draw your vertical lines. Oh, look at that one. See how that repeats? So this is not a function. Number 9, none of the x values repeat, so it is a function. 10, look at your x values. The -2 repeats, so this is a no, it's not a function. Okay, number 11, look at all your x's. None of them repeat, so it is a function. Number 12, draw your vertical lines. It only crosses one time with each vertical line, so it is a function. Number 13, -1 is with 5, 0 is with 1. 0 is also with 5. See how it has 2 arrows on the x side coming from one number? That tells us that 0 is with 1 or 3 and 5, so it is not a function. That's a tricky one. A lot of people miss that one. 14, vertical lines again. It only crosses the graph once, so it is a function. 15, vertical lines. It is a function, and this is actually called a linear function, which we are going to get a lot of experience with over the next few weeks. Number 16, do any of the x's repeat? Yes. So that is not a function. 17. Oh, right away. Look at that. Those are repeaters. It fails the vertical line test. So this is no. 18. No repeaters. So yes. 19. Look and see if there's any 2 arrows coming from x. And there are not. So this is a function. Then the last one, vertical lines, doesn't cross 2, so this is a function. So yes. All right, go ahead and glue this in your journal on the next page. So on the assignment, make sure whenever you do the mapping, x's are on the left, y's are on the right, but don't repeat them. So I wrote them in least to greatest order, and then I can do the arrows. So 8 to 2, 4 to 2, 8 to -9, and 7 to 5. So is this a function? If you look at no, x's repeat. So no, and I would put 8, or x equals 8 repeats. But if you know it from after you graph it, you can do that. Okay, let's go ahead and look at discrete, domain, and range. I want to look back at the vocabulary real quick. Discrete, a function with distinct and separate values. When graph, values are not connected, only whole numbers. So that's what discrete is. So when we talk about discrete, we're just going to be talking about ordered pairs or points on a graph. That's it. And we are going to start with domain. So domain says the set of all possible input values of a function. So domain is X. And what I try to teach is doxin, like this. D-O-X-I-N. So dachshund is for domain because it's domain, X, and input. Domain, X, input. And then the other one for range is ride. R, Y, D, E. Range is Y, which is our dependent variable. Dachshund ride. So you'll hear me say that, and that's what I mean. So I'll say, is it dachshund or is it ride? Dachshund is X. Ride is range for Y. I'm going to go ahead and cut on the dotted line. Only the top layer, not the bottom layer. All right, the domain is a set of all possible x values of a function. Other names for domain are input and also independent. And just, I'm going to put x values. So for domain, we are just listing out the x values, just making a list of all the possible x values. So from ordered pairs, we're just going to list out the x values, and we're going to put these little squiggly braces, okay? Squiggly braces is like this. See how it's like a set. That's what the squiggly brace means. It's a set of these ordered pairs. So we're going to do the little squiggly. It's like an S and then a backwards S. S and then connect it with a backwards S, and that's your little brace. Let's list out all the x values. I'm going to highlight them. If you want to highlight them, go for it. And then make a list. So 0, comma, 1, comma, 2, comma, 3. And then close your brace with a backwards S and a forwards S. So it's kind of the backwards of it. Okay. From number 2, it says, what is the domain of the function f of x equals 2x plus 3, given the range? Okay, range is ride, which is the y values. So let's make a table where we have x, and we have f of x or y. F of x and y are the same. It says, what is the domain if the range is that? So the range is the y values, the f of x, -1, 3, and 7. We're going to use our calculator for this because that's the easiest way to do it. You can also use Desmos. But let's go to our calculator. If you don't have it, go grab it real quick. We're given this function 2x plus 3. So go to y equals and put in 2x plus 3. So y equals 2x plus 3. So we're writing down the steps. I guess I should put calc. In the calculator, we're going to put in y equals 2x plus 3. How can I go to a table that looks like this? How do I get there? Do y'all remember? How do you get to the table? you do second graph for the table. So go second graph for the table, and we want to find where the y values, or the f of x, is -1. So where is it negative? So -1 is with -2. And then where the y value is 3, where is that? It's right here. So what does that match with? 0. And then we want to find where the y value is 7. So it's right here. And that is at 2. So the x values are the domain. So once you find them, using our calculator, we'll make a list. So do the little squiggly brace. -2, 0, and 2. So we used our calculator for that one. All right, so we're still finding domain, which is our x value, input, and independent. Let's go to number 3. We're just asked for the domain. What's the domain? X. So I'm just going to highlight them. And then write them as a set. That little S and a backwards S. So -1, 0, 1, and 2. Then number 4, what's our domain? It's all the x values. So make a list. The graph. The graph, we just want to know the x values, right? So I'm going to highlight, or I'm going to label the x-axis on both of these graphs. And go ahead and highlight the x-axis. Because discrete is just the x values of the points for the domain. So we want to know how far on the x-axis the values of the x go. I think the easiest way is to draw a table and fill in the points that we have here. So we're going to name all the points, starting from the left to the right. So let's go to this point right here. We need to know the coordinates to that. It's going to be -1, -5. Y'all see that? Okay, and then this point would be left and right 0, but down -3. So 0, -3. And then this point, the coordinates for that are 1, -1. Then this point, we're going to go over 2, up 1. Lots of points. Let's see. This next one, start at the origin. We're going to go right 3, and up 3. And then this point, we're going to go start at the origin. 1, 2, 3, 4, up 1, 2, 3, 4, 5. So the domain is just a list of x values. So highlight your x values. And you would make a list like we've done here. So there's not much room, so do the best you can. So all I did was write it as a list, a set of the x values. Okay, look at the next one, x, y. We need to write out all the points and then list out all the x values. So start with this one. Start at the origin. How far left do I go? -5. And then up 1, 2, 3, 4. Then the next one, -2, 2. Go back to the origin. Go right 1, up 0. And then the next one, 1, 2, 3, 4. Down -2, or down 2. So we're talking about the x values. So now just make the list. So tomorrow we will talk about range.